Hello and welcome back. So in this video we are going to discuss the fifth and last angle property, and it is known as alternate segment theorem. So it states the angle between a tangent and a chord at the point of tangency equals the angle made in alternate segments. So first of all, as we need a chord at the point of tangency, we have taken a circle with center O, and here is a chord TL, and I need a chord at the point of tangency. It can be anywhere in this circle, so I am taking this chord over here with the other endpoint as P. Now this property states the angle between the tangent and the chord, so it can be over here if we want to take the acute angle, or it can also be the obtuse one. So first we are going to discuss the acute angle. So it states that it equals the angle made in alternate segment. So what is alternate segment actually? As we see, PT chord is dividing this circle into two segments. One is the minor segment, this one, and this one is the major segment over here. So as we have taken angle in the segment over here, so segment opposite to this will be the alternate segment. This in this case is the alternate segment over here. So any angle in this segment shall equal angle x. Suppose that the angle at a position q over here, so it will equal the angle x. So this angle at position q, or the position q can be anywhere in this alternate segment or the major segment. So according to this property, the angle, if I say this point is M, so MTP angle, MTP, as it is formed at position T, it shall equal the angle PQT. So this was the property, as we see the diagram from the book, and again here we have a tangent with, so here is a circle with a tangent AT passing through the point A, and as we can see that the angle between this chord and the tangent is given x. So we see the angle in the alternate segment opposite to that chord, it is y, and according to this property it states the angle between a tangent and a chord at the point of contact is equal to angle subtended by the chord in the alternate segment. In this diagram, angle x equals angle y, and it is abbreviated as angles in the alternate segments. Now here is the first question. It states, in each of the following circles, identify the angle that is equal to x and label it as y. So in first part, as we see, here is the tangent, and angle is made between this chord and the tangent. So angle opposite to this chord in the alternate segment will be y, and as we know, this shall equal x, because angles in the alternate segments are equal. In the similar manner, the angle x in B part is made between the tangent and this chord. So as we see, the angle x is made in the major segment, so the alternate angle will be in the minor segment over here, just opposite to that chord. So it will be labeled y, and again x shall equal y. In the similar manner, in third one, we can see the angle is made between the tangent and this chord over here. So the angle in alternate segment will be opposite to this chord over here, and again they are equal. And for the last part, D, as we see, the angle is made between this tangent and the chord over here. So the angle in alternate segment, as we see, this angle x is made in the major segment, so this segment over here is the alternate segment in this case, and angle in this segment is made at this point. So this angle over here equals angle y, or directly it equals x. Now coming to the practice now, question 11 from the book. It states BC is diameter of the circle and TA is tangent to the circle at A. We can see that this TA is the tangent and BC is the diameter, while BCT is a straight line. Given that angle ABC is 33 degrees, we can locate it over here. Find angle CAT. First, angle CAT is located over here. It is between the tangent AT and the chord AC. So as it is the angle between a chord and a tangent, so there must be an angle in alternate segment. So as we see, the angle in alternate segment is 33 degrees, so these are equal. Angle ABC equals angle CAT. So angle CAT must equal 33 degrees. That was the first one. Now second one, angle ATC, and if we look at angle ATC is formed over here and before. So in order to find this angle, first this angle is in two triangles. It is in triangle ACT as well as in the triangle ABT. So as it is given that BC is the diameter, and if BC is the diameter, then angle at position A shall be a right angle, because that is angle in a semicircle, and we have located this angle as 33 degrees. So we are going to discuss the triangle ABT, and let me draw this triangle over here. Like this side is 80, here is the side AB, and then it goes side BT. So as we know, the angle over here is 33 degrees. The angle at position A is 90 plus 33, and that is definitely 123, and we have to figure out this angle. And as we know two angles of the triangle, we can directly find the angle ATC by subtracting the sum from 180 degree. 180 minus sum of 123 and 33. So as we add to it is 180 minus 156, and after we subtract it is 24 degrees. So angle ATC for this practice now was 24 degrees. So this was the practice now 11, and this was last and final properties from the angle properties of circle. And in coming videos we will first discuss the exercise 9b questions, and then we will move to past paper questions, and we will discuss the past paper questions in detail.